Go.
Chapter 5-2, written A, 22 through 50 even. So now.
Why'd you stop in the first place?
To make them lose a bet.
You lose both wrong anyway.
Oh, no. 21! 21. The sine of 1/2 x times the cosine of x minus the sine of 5/2x cosine of x has to equal cosine cubed of x times the square root of sine of x.
Sorry, would you speak English?
Now, it is ugly. Not going to lie, it is ugly. But here's what you need to understand. With exponents, when they're tied to multiplication, what do you do with them? You add them. You add them. Okay? So we're going to do the GCF concept here. What's in common between the first two terms here? This term and this term. What's in common?
Sine of x.
Cosine is common. What else is in common?
Sine half of x. Exponent of x.
Sine half x. So if I pull out a sine half x and a cosine x, if I pull that out, I'm left with what?
1
minus
sine of 4 over 2.
4 over 2. Good. Colton, you're on it. You took a
2x.
smart pill this morning.
No, it's the glasses.
The cosine goes away. Why is that 4 over 2? Because if I'm going fishing and I'm pulling out my GCF, and if normally you would add them together, if I'm dividing, that means I'm subtracting 1 out of that 5. So 5 minus 1 is 4 over 2, right? What is 4 over 2?
Wait, time out. 2. 2.
That is actually going to be squared. Now, time out. What?
Where do you get the 1 minus?
I'm pulling out a half out of 5 over 2.
No, where's the 1? Because you pulled out a sine half x, a cosine of x.
Oh, this one you mean?
Yeah.
That whole thing I pulled out as a GCF. That's sine 1/2 x cosine x. That's what I'm pulling out as my GCF. So if I divide it, that gets 1. Now, think of it, Debbie. What is 1 minus sine squared? Cosine squared. So I have sine of 1/2 x, cosine of x, times the cosine squared of x. Now what's cosine times cosine squared?
Cosine cubed.
Cosine cubed. Now, when you have a power as a fractional power means power over root, remember? So that means my power is a 1, and I'm taking the square root of that. So give me the cosine cubed of x times the square root of sine of x.
It doesn't matter if you have sine, square root of sine of x. It doesn't matter.
It doesn't matter, but what generally happens is you guys have this tendency to extend that, love a little square root over the cosine cubed of x. And it's not underneath there.
That doesn't look.
It's not beautiful. It got hit with the ugly stick a few times, but it's still a problem. Can I move on?
Yeah.
Don't hurt happy pants all day.
Not really. You already clicked me off the button.
I've
seen it.
He sold the chair. I
Well,
it and he
technically, soft.
Okay, 49.
Don't start with me, girl.
49. Tangent cubed theta minus 1 all over tangent theta minus 1 is equal to tangent squared theta plus tangent. That's not theta, that's not theta.
What's the B?
That's a Christian
Theta.
fish.
She was at work yesterday
Yes, okay.
with the B on it. We never even knew anything about it.
Just a placeholder. Guys, if you don't like the alphas there, you can put theta, you can put x, you can put anything you want to do. It doesn't matter. But I kind of like draw fish. So draw your fish.
I like turtles.
So whatever you want.
Like turtle.
Now, a cubed minus b cubed is what we call the difference of cubes formula. That's going to be a minus b times a squared plus ab plus b squared. This is a formula. Okay, this is going to be the difference of cubes.
We gotta memorize that.
Now, you can only use this whenever your terms are perfect cubes. Tangent cubed of alpha. Is that a perfect cube? Yes, because tangent times tangent times tangent is tangent cubed. That's a perfect cube. So what this is implying is is that A is equivalent to the tangent of alpha. Now B is 1 a perfect cube. Well, what number multiplied by itself 3 times is 1? 1 times 1 times 1. So this means that B is 1. All you're going to do is you're going to plug this into your formula. Well, that means I'm going to do A minus B. So A is tangent of alpha. B is going to be 1. So that's tan of alpha minus 1. Go to the next parenthesis. That's going to be A squared. Well, what is A squared here?
Tangent squared of x.
Tangent squared of alpha plus what's A times B?
Tangent.
Tangent, and then what's B squared?
1.
All over
Oh.
all over my denominator, which is going to be tangent of alpha minus 1. That was given. That was given in the problem. The only thing I changed was factoring that difference of cubes formula there, right?
So when you do this,
Don't you ever do that again?
Wait, do you always put it over A?
No. This is the formula. This is the formula.
Yeah, we'll just really hard.
You don't like blue? I really like blue.
I like it if I can stare at it, but like looking back up at it, you gotta put it back in.
Okay, well,
Kind of trippy.
you
I
don't
can
like
see
the
it
black
just
blue?
fine. No, I like
You
the
like
other
blue.
colors, I just don't like blue on
I like red and green.
I like turtles.
Blue's like.
Those
I
are
like
your
not
shades.
doing this because my brain hurts
Yellow,
when
yellow.
I do what you're doing. Yellow.
Hey.
Squirrels.
Hey,
second baby.
now, what we have to do here, all I did is I applied this formula right here, the A cubed minus B cubed. I applied to the numerator only. Okay? I used that formula and I put it in my numerator.
I got you now.
This is already there. That is not part of the difference of cubes. That was the given denominator, so I just tacked that on. Do y'all understand that? So now, tangent of alpha minus 1 is gone, and I'm going to be left with tan squared of alpha plus tan of alpha plus 1, which is what I wanted.
Whoa. That's pretty easy.
It was easy as long as you knew the formula that you had to use to factor.
Yeah, I work just like
Wait, don't move it.
What's your open up?
Not African.
Okay.
I don't understand what's going.
It's Friday. That gets in there.
Now, I will say, if you need the sum of cubes, sum of cubes formula is going to be A cubed plus B cubed is equal to A plus B times A squared minus AB plus B squared. That is the sum of cubes. You may need that formula too. You may need that formula too.
So all you do is change.
I'll be honest, I ain't gonna know.
How do you know when you use the sum of cubes and the difference of cubes? You're looking at two terms.
When you got it.
One's attached by addition, that's the sum. One's attached by subtraction, that's the difference. And they both have to be perfect cubes. Examples of perfect cubes would be 3 times 3 times 3 is 27. 27 is a perfect cube. 4 times 4 is 16 times 4 is 64. So 64 would be a perfect cube. You understand that? Okay? X to the 6 would be a perfect cube. Because what am I going to multiply by itself 3 times to get x to the 6? X squared times x squared times x squared. 2 plus 2 plus 2 is 6. Do we understand that? Maybe a little bit like that.
We act like we know.
33 is ugly.
So does this mean our homework's gonna be ugly?
Math means ugly. Completely.
You just promised you her ugly.
No, I said math.
Or technically she's a math teacher.
So she's a public teacher? I'm misunderstanding.
I'm just putting,
I don't agree with
I'm
her.
just applying the concept here.
That's,
You're gonna
that's
apply
what we're trying to do.
concept.
And we're on your side, of course.
I wouldn't fit in a locker, so.
Right, Chip and Dale.
You should have described it as
I
math
don't know.
problems.
You ready?
Yeah, let's do
This is absolute value of cosine of theta.
this. Okay.
Okay, we need the left-hand side to look like the right-hand side. We are going to tag this lovely little square root symbol right along with the line. Okay, we're not going to leave it there. We're just going to don't know what these are. We're just going to let it chill for a little while, okay? If I were to have just this junk underneath the radical, how would you begin to do that problem? You would multiply by its conjugate. The conjugate is going to be 1 plus the sine of theta, right? Do we understand that? So, how many 1 plus sines of theta do I have up top? 2. We're going to write that down as squared. You know why we're going to write that down as squared rather than foiling it? Because what is the opposite of a root? A power. If I have a square root, the opposite, that would be a power of 2. If I have a cube root, the opposite, that would be a power of... If I have a cube root, the opposite, that would be the power of 3. If I have a fifth root, the opposite, that would be the power of 5. Okay? So since I see that these are going to be opposites to each other, that's going to do what eventually? The power and the root would cancel out, right? Eventually. Now, the denominator. I'm going to go ahead and FOIL this. 1 times 1 is 1 minus sine squared of theta. Now, what's my denominator that I want? Absolute value of cosine. Well, tell me, folks, what do I have to do here? What's 1 minus sine squared of theta? Cosine squared. Now, separate these. Take the square root of the top, take the square root of the bottom. What happens if you take the square root of 1 plus sine of theta squared? The root and the power cancel, and I'm going to be left with 1 plus the sine of theta. What happens whenever I take the square root of the bottom? Why is it the absolute value of the cosine? Obviously it is because that's what we want, right? But why is it? You can't take the square root of a negative number, right?
Right.
Why is it the absolute value?
Because the square root it's only on the math.
It's on both of them, okay? You can't take the square root of a negative number, which is why it's the absolute value, which is why we have to keep it always positive. But keep in mind, it can never be 0 in the denominator. No. So keep in mind, cosine of theta cannot be 0. That's kind of like a domain restriction that we have on there, just so that you're aware of that. Because if you divide by 0, then the whole thing's gone, right? All right. Now, here's tonight's homework. We got a lot going on in it. It's not easy. Okay? So what I suggest doing, guys, I can sit here and I can do all types of problems for you forever and a day. But until you actually start trying them yourself, working on them, are you even going to have a clue what to sub and when to sub? Now, so what do I want you guys to do? The rest of the time today, we're out of here at what time? 48. We got a solid 10 minutes here, 12 minutes here remaining for you guys to actually work hard on this stuff. Okay? So I want you guys to get out your books, get out your homework from section 5.1 and 5.2, especially 5.2, and I want you guys to work on it. If you want to work with a partner, you may. But keep in mind, whenever I say work with a partner, it's not sit there in time and talk about everything that you want to do, talk about prom and anything else. I want math. I want you guys to work. I want you guys to understand what you're doing. Okay? So, lights up.